Hey guys, today we are going to be looking at how we can use a concept map to organize our notes and help us study. What we're going to do is, you guys are going to watch this video. I'm going to try and keep it short so that way you're not going to be bored. And I'm going to show you how to make a concept map about earthquakes, and then you guys are going to be using the website that is linked in Classroom to make your own concept map, but you're going to do it on volcanoes. And you're going to use both of these then to help you study for your test that we're going to be taking after we come back from Thanksgiving break. Basically what we do, it's a flow chart. We have many different ways that you can set it up. No two maps are going to look the same, but it's just a way to outline our thought processes. So I started with putting earthquakes in the middle, and I've got a couple topics around it that we can then branch off and go into more detail and organize these thoughts. If you guys want to work top to bottom, that's 100% okay. If you want to go left to right, that's fine too. If you like going from the center out, whatever way is going to help you study will work. So for me, earthquakes is going to be in the center. And the first thing that we're going to need to know about earthquakes is where they occur at. And there are a couple different places where earthquakes are going to occur. We see that they can happen at convergent plate boundaries. And I'm just going to put a box around this. They also can occur at divergent plate boundaries. And these two happen as the plates are either coming together or being pulled apart, but most commonly we see that they are going to occur at transform plate boundaries. And this is where we see a lot of friction is going to be preventing these two plates from sliding past one each other nicely, and it's going to create a lot of stress on these rocks, and when they overcome stress, they're going to release the energy in the form of an earthquake. One other place where we see earthquakes that can occur at is something called a fault zone. I'll put my box around that. A fault zone is basically a break in the rock, and that's what a fault is. And it's along this fault where earthquakes are going to be occurring. So 4 different places where we can see this happening. When we have an earthquake occurring, we need to know a little bit about the anatomy of it. So this will be my next box. Anatomy of an earthquake. We know that the place where the earthquake first occurs, this is called the focus. And this is going to be inside the earth. I'll get my box drawn there. If we go directly above the focus, we have the epicenter. I'm just going to kind of draw an arrow here for this one. I guess I didn't make my box big enough. Our epicenter, and this is going to be on the surface of the earth. Directly above our focus here. Okay, first part, where do they occur? Second part, what does an earthquake look like? We have our focus inside the earth, our epicenter on the surface directly above it. After we see the earthquake happening, it's going to release seismic waves. And there are a couple different seismic waves that we're going to need to know about. We have our body waves. And then we have our surface waves. And we're going to break these down and look at what's the difference between the two. Our body waves are going to move through a medium. That medium being solid, liquids, or gases. And we can write that here. So they move through material. We'll just call it material. And we have 2 different types of body waves. We have a P wave and we have an S wave. P waves are the first waves to arrive, and they are going to be compressional. And they can move through all solids, liquids, and gases for our P waves. Our S waves, now these are going to move materials side to side. They appear second on our seismogram, and they can only move through solids. they cannot move through liquids. And this is actually how we figured out that the core was going to have a liquid outer core, because there was a shadow zone where no seismic activity was recorded after an earthquake. So these are two types of body waves. We also have two types of surface waves that we talked about, and these are going to be the slowest type of waves, but they cause the most damage. Box here. Slowest type of waves, they cause the most damage, and we have two types here that we looked at. One of them was called a Love wave, and this kind of moves material perpendicular side to side. And then we have our Rayleigh waves. And these are going to move in a circular motion. And these guys on the surface cause the most damage. Once we know these two different types of waves, we can then try to locate the epicenter of an earthquake. So if we go here, our next one that we're going to start at, locate the epicenter. And we spent a few days working on this. Basically, we know we need 3 seismograph stations. And we will look at those readings, and we will determine the difference in the S and P wave time interval. From there, we're going to use our graph to find the distance. Once we know the distance, we get to use our compass, and we will plot those circles on a map. And where those 3 circles are going to interlap, that's going to be your epicenter. Once we know our epicenter, we then can be able to measure how big or how strong this earthquake is. And we have a couple different ways that we can measure. We can look at the magnitude, or we could look at the intensity. When we're talking about the magnitude, this is the strength of an earthquake, and we use the Mercalli scale. I'm sorry, we do not. We use the Richter scale. And this is going to be a log base of 10, so as we increase one number on the Richter scale, it's going to actually jump up by a factor of 10. With our intensity, this is going to measure the amount of damage caused by an earthquake. And this is where we're going to use the Mercalli scale. And basically it's going to be rated 1 through 12 on how much damage is going to be caused. This is obviously going to depend on a couple things, like how long was the earthquake lasting for, what was the magnitude of the earthquake, how far away from the epicenter were we, what type of human infrastructure, and then just the geography of the land. So this really depends on a lot of things. And if we had more time, I'd write those all out, but we'll just say it depends on multiple factors. The last thing that we talked about in our notes was safety before, during, and after an earthquake. So we could have a box talking about before, box talking about it during, and after an earthquake is going to occur. Before an earthquake, because we can't really predict it, we might have a little bit of early warning signs. There might be a foreshock. We could watch for that. Or if we, know that there's a seismic gap, we haven't had any earthquake activity in this area for a while, we might be able to predict that one will be occurring. But there's not really 100% certain way we can predict it. But before, we can have a plan. And that plan would be, what are we going to do? Where are we going to take shelter? What happens if we're inside a building or in our car or wherever? We need to know what we're going to do to stay safe. During an earthquake, basically you want to take cover. Stay away from anything that could fall on top of you. So stay away from large objects like a tall bookcase. Stay away from windows, any sort of glass that could break and cut you. Stay away from tall buildings if you're outside. You don't want anything to fall on you. After an earthquake, be cautious. Take care of yourself first. Watch out for any downed power lines, any broken gas lines that could cause a fire or eruption. But basically, take care of yourself first and wear shoes. And this is basically what we talked about in our chapter on earthquakes. And I know it's looking a little busy here. With you guys using the website that's linked below, you will be able to make it look nice. And you can move the bubbles all around and actually give yourselves room to write all of the information that you need to study. I will probably make copies of this for you if you want. That way you can use it to study, but I would really suggest is go back through and watch this video a second time or a third time, and definitely go back and look at your notes because that's going to help you study for the test as well. If you have any questions, feel free to shoot me an email. I might be able to get a hold of you at some point over the next couple of days here, but if not, I will be back in class on Tuesday.